first off, I'll introduce myself. My name is William Welch. I'm Technical Training Manager here at Sudol, USA. Basically, I'm responsible for teaching people about all this sorts of stuff. So hopefully this will go well. I've been asked to talk about the PU35 and why specifically you might want to choose it or look into it specifically. And it really comes down to these characteristics specifically, all kind of hinging on the reliability of the product. We're going to talk about packaging some. We're going to talk about tooling some. No bubbling, and I'll dig into why that's a really big deal and what's going on there. We'll talk about adhesion some, the increased shelf life from a number of factors that we've got kind of going on, as well as the PU35's elastic properties as well. I want to start off with talking about tooling, specifically the fact that our product doesn't slump. To kind of talk about that, it will show a little bit more what exactly I mean by that. I do have a quick video for that. I'm going to go ahead and let that play as it kind of speaks for itself. So what you're seeing here is specifically how we test slump. This is based on ASTM methods, standard test methods. So this is basically how everybody tests slump. Basically, you've got this jig, and then you let it out. You can see that competitor products will slump quite substantially, where ours will barely move, if at all, which is great because it means that when you put the product, it stays where you put it. You don't have to worry about it moving on you as you're tooling it, making vertical applications noticeably easier. In addition to that, you'll notice that ours over there on the left has that much smaller string, making tooling vastly easier as well. Basically summarizing that, easier to apply, easier to tool, making it less stringy. And that really has to deal with the fact that we don't have to put the same amount of solvents in our PU35 as some of our competitors do, based on some of the other things that we'll talk about later. And I'll kind of hit on all of that again when I get there. Now, a really big one is bubbling. Many polyurethanes, especially older polyurethane formulations, bubble if they're exposed to excess moisture in any way. Ours doesn't. What I've got here are two videos. On the left is a standard pre-polymer, so what any number of polyurethanes can be made with. And then on the right, I have an example of ours. Now, it's really important to understand that pre-polymers only end up making about 35 to about 40, 50% of a finished sealant formulation. But what I want you to take away from this is how dynamic and volatile and arguably almost violent the bubble formation in the video of the left is. I'm not enhancing the speed here at all. This is real-time sort of bubble creation in these formulations. So I'm going to start them at the same time. There is no time lapse here. And you can kind of see just how dramatic. Now, it's important to note these are very thin products or components, so there is a little bit of entrapped air just inherently, but you can see just how insanely dramatic that those bubbles form there on the left. In addition to that, I want to keep your eye kind of to the left bottom corner, as you can kind of see the cure line eventually rupture due to all of the pressure from all of the carbon dioxide that has been trapped within that curing mechanism, or that curing line, and how it just kind of pops out and flows everywhere. Where ours doesn't do that. And that comes specifically from the latent hardener that we use. And I'll kind of get to show you a finished product. So what those prepolymers translate to in final actual sealants. So as we cut into this, you'll notice that ours, they aren't homogeneous all the way through. There aren't any bubbles or pockets, where with this competitor product, you'll see that there are bubbles and pockets in that center. And it's not super great right here, but we'll see a really nice couple of pictures of it there. And then as I jump to this next slide. So the issue here really comes from the fact that you'll notice that the edges of that sealant bead on the left have bowed, so it deforms on you. So you might have tooled it nice and clean, and now you've got a little bit of a raised surface or raised area. In addition to that, all of those bubbles are pockets that moisture can get into, completely ruining your sealant as it kind of moves and flexes, and all kinds of opportunities for it to tear. Now, the reason our product doesn't do that, ours comes with an additive package that basically causes us to skip the part of the chemical reaction where carbon dioxide is created. That additive package is called a latent hardener. It's just something unique to our product specifically. And as such, we don't have to worry about carbon dioxide, which is great because in many of the older situations or with older formulations, you'd have to worry about even the slightest bit of moisture or excess moisture causing you all kinds of problems. You don't have that issue with our product. So high heat, high humidity situations aren't a concern in that regard. On the adhesion side of things, we got pretty decent adhesion without primer to things like concrete, damp concrete, aluminum, steel, glass, Kynar, wood, vinyl siding, and tons of other different stuff. It's really important to us that we talk about our primerless adhesion. In many cases, you have to, if you're using other competitors' products, you might have to use a primer of some variety to get the same kind of adhesion that we get without one. And that's really important to us. And again, it's important to note surfaces do need to be clean. In a perfect world, they're dry as well, just to make sure that we're getting optimal adhesion. This is true for any product out there. Don't be worried about the fact that I just said it's fine with moisture and then I said stuff needs to be dried. It's just talking about best practices here. Any sealant was going to mention those things. Also, it's important that if you're looking to use it with some plastics like polypropylene, polyethylene, polytetrafluoroethylene, EPDM, TPO, all of those, you do a suitability compatibility test first, just because it may not perform the way you would like. It may damage those substrates in some way, or the sealant might get damaged as well. It's really hard to account for all the varying 30 million different types of them, which is why we recommend that suitability test. Going into packaging. So a number of our competitors use what we call in the industry fiber foil cartridges, which are essentially a paper towel roll with a thin layer of aluminum foil on the inside. For formulation group that is generally trying to avoid moisture any which way it can, a little bit of cardboard, a little bit of aluminum foil, not really great at keeping moisture out and being resilient to the environment. Cartridge blowout happens all the time with those fiber foil cartridges. They damage very, very easy. We don't do that. We package ours in an aluminum cartridge, which is something typically you're only going to see in high-end sorts of packages for high-end polyurethanes here in the United States. We do that for all of ours. So that's not a concern there. Because of that, we don't need the same kind of sealants or kind of solvents that our competitors need in order to ensure the material gets out of the cartridge, because we're inherently more stable within that cartridge. As such, we can no longer shelf life. So what I've got here is a representation of shelf life. These products thicken as they age. You can see that our almost well out of shelf life product, accounting for shipping and a little storage here and a little storage wherever you're at, is still many times just a random off the shelf of one of our competitors' products. So you're going to get more consistency with the way ours behaves, which is what you're looking for, right? You want this thing to do what you want it to do every time. Then I want to talk about elastic properties just a little bit. I got a little bit of a video here to kind of talk specifically about what those mean, kind of show you what we're talking about when we talk about elasticity, kind of in general here. And then I'll throw some numbers at you, kind of representing what our PU35 specifically is. So this dog bone test that I'm putting up right here is pretty common here in the industry. It's typically what most people use. Basically, you take it out and you stretch it and you see when it breaks. So that's just a great example of that. It's pretty common here in the industry. And you can see just how much that actually extends. Another is this one, kind of does both, gives us some test of adhesion as well as flexibility given those substrates, which is another great indicator as well. And both are used as kind of in conjunction with something that I will talk about here in just a moment. They're both used in the as tests for the standard that I'll talk about here in just a little bit. But you can see that this product is incredibly flexible. All right, now to actually put some numbers in the things you'll probably more recognize. So the PU35 is an ASTM C920 class 50. Due to internal testing, we have had it externally validated to 35%, hence the name. We are working on getting that external validation updated to that 50% as well. So it's just a flat 50 all the way across the board. In addition to that, we looking at our competitors were twice the elongation when tested with concrete and 1.5 times the elongation when dealing with aluminum. So we're more flexible than our competitors. We're also PennDOT approved. So great if you need it in that angle as well. And it kind of summarizing again, it really all comes down to reliability. No slump, no bubbling, more elastic, long-term stability. Your cartridge is going to do what you expect it to do when you need it to. You don't have to worry about any of those other headaches that you might worry with some of our competitors. In addition to that, we're a global supplier, and then we are ISO certified here in the US as well as abroad. So that's the PU35. I think that mostly summarized. This is what I was trying to get through relatively quickly for this short little conversation. If there are any questions, please feel free to ask.